Hi, in this video, we want to take a look at match merging data in R. All right, so match merging is where we combine two data sets. So let's say that I have one data set, maybe we've got homework scores in this data set. We have this data set with test scores, and I need to combine them. Well, in each data set, I have the student's name. So what I want to do, I want to put them together, but maybe some students didn't do homework, but they took tests. Maybe some students took tests, but didn't do homework. So I can't just put them adjacent to each other. So if I was to bind the rows, append the data, I would be matching up the wrong students together. So that would be a problem. So what I need to do, I need to take the names, and the names from each of the data set, I need to arrange them into, I sort the data, and then I go through, and R will make sure that things are lined up in the correct manner. Okay, so match merging is combining two data sets with different variables. So in my example with my hands is homework and test scores. They have a common bivariable. The bivariable for this is going to be the students' names. Okay, now by, that term is what SAS uses. So I'm just going to use by because that's a classic way to go. Typically, we'll also call it an ID variable. It's very common. All right, so we have four major types of joins. Inner join. All right, so in this situation, this will only be taking the students that have both homework and a test score. So both homework and a test score. If a student did not submit homework or a student did not submit a test, they will not be included in an inner join. So here, only subjects in both data sets are kept. All others are excluded. This will, of the four joins, this will give us the fewest observations. And so because of this, we need to be prepared for data being omitted. All right, the next one, I'm going to skip down to full join. All right, so here, everybody's kept, and every single observation is in there. This will give us the most in there, but the most observations because there's nothing filtered out. But we have to be prepared for missing values. All right, now, a left join. All right, so we have two sets. There's like a first one and a second one. We're going to call the first one the left data set, and we'll call the second one the right data set. Why is that? Because when I do this, the first one is going to appear on the left in my data frame. All the columns that are in that one will be on the left, and when I'm done, the second data set's columns will be on the right. So that's why it's called left join, right join. In a left join, all observations from the left data set, the first one, are kept. But any observation in the right that doesn't match somebody in the left is kicked out. So left, everything is kept. In the right, anything that doesn't match into the left is kicked out. A right join is the other way around, in that all observations from the right data set are kept, but if there is an observation in the left that doesn't match the ID variable in the right, it gets kicked out. All right, so left join, all subjects in the second set, but not the first, are all the observations that are in the second, but not in the first, are excluded. So this keeps all subjects in the left data set. Remember, left refers to the first data set. Right join, any subject in the first but not in the second is kicked out. All subjects in the right second data set are kept. All right, now when we're talking about match merging or joins, match merging is like SAS terminology. Joins is a more modern way. Joins is where you'll probably hear it the most. SQL uses the term joins. DeepPy-R uses joins. Base R uses the term merge. They all mean nearly the same thing. All right, this can take a while. If you're dealing with big data sets, this can take a while, honestly. But we can speed this up by filtering out data. that we're not going to use before you do your join. So if you know that there are columns and rows you're not going to be using in your project, go ahead and get rid of those before you do your joins. And also, a way to speed things up, if I have an ID variable, and as I'm combining things, if I have my data already sorted, that can speed things up. So there might be situations where having my data sorted for some of the operations may improve performance on the computation side. So if I keep my data sorted by what I'm going to be merging by, or nearly sorted, it can speed up the time by quite a bit. All right, so now let's go ahead and let's do an example. So here I'm going to build an example data set. So here, this is going to be my test data set. And so over here, I've got my quizzes, and I'm going to want to put them together. All right, now, something I want you to notice is that in the test data set, I have the letters 1 through 8. So that's A, B, C, D, E, F, G, H. And then and that's my ID variable. This is going to be my by variable. Over here, the ID is going to be the letters that go, the 5th through 12th letters. I'm not going to sing it this time for you. And then we have the other data. Now, I made attendance match the row number over here, and attendance matches the number of the letters number in the alphabet on the ID variable. And just to make things a little bit clearer so we can see what's going on, I made all the numbers end with 5. In quiz and homework here, I made all the numbers end with zeros over here. All right, so here's my test data. I have ID, test, home, attendance, quiz, ID, quiz, homework, attendance. Okay. And notice that attendance is the same across both of the data sets, but the homework scores are different. And this can actually happen in real life, that I have the same field in 2 data sets, but they're actually different entries. Or I may have the same field name and they match across the different data sets. So something like birthday, if I have ID variable, let's say like social security numbers, and then I have, or NID, let's do NID because that's more parallel since we're talking about University of Central Florida. NID maybe over here could be birthday. And here this is NID and here's birthday. Well, this could be test scores from one class, homework from one class. Over here, this might be the quiz and homeworks from a different class. That could be our scenario for where we're getting this. All right, so base R uses the merge function. And basically we set the parameters to make it into a left join, right join, inner or full join. If I'm doing an inner join, I set both alls to false, which is the default setting. For full, I set both equal to true. And then for left and right joins, I set true for whichever data set I don't want filtering happening on. Okay? And if I have sort equals true, this is going to return sorted data. And it will sort by the columns that we are combining on and by X column. All right, now something that's going to happen with this function, so here the left data set is called X in the parameters. And so when I'm all done, if anything that's by in both of the data sets, it's going to have the name is going to be the X version. So if I had, let's say, one data set NID, but then another data set, we just call it ID. If NID is in the first data set, NID will be the name that's used in the resulting data set. Now, by default, repeated columns will have a suffix of an X or a Y. If I'm merging multiple data sets with redundant column names, consider placing a suffix on there to make it more clear. So if I'm in a situation where I'm putting on like 5 different columns, and let's say they have redundant names, I might get, you can get some really wonky suffixes added onto your data. And this is really an issue if you're putting in like 3 or more data sets are getting combined together to get everything on there. Like SQL forces you to deal with this kind of stuff on your own before, so it doesn't even become an issue. R doesn't force you to do anything about it, but what ends up happening is it just starts appending stuff. R wants to actually, SQL doesn't do anything for you. You have redundant column names, and which can cause problems down the road. With R forces you to have syntactically correct names for the output on merge. And by doing that, there's advantages, but also you can get some ugly looking output for your column names. You just have to be aware for that. Bring in some coffee. I'm the #1 dad. All right, so I'm gonna merge my test set and my quiz set. Test is the X data set or left on this one. And if I put both of the alls equal to false, then I'm going to be doing an inner join, and you can see I only get 4 observations. Okay. Well, now let's do a left join. So left join, X is equal to true, Y is equal to false, and I can see that all the IDs that correspond to the left that were originally in the left data set are kept. Any of the quiz data that's for a student not in the test set gets kicked out. Now, I move on. Oh, and now something we need to notice, I forgot to say this. Notice that homework, since it's in both data sets, it said homework.x, homework.y. I've got attendance.x, attendance.y. So even though attendance is redundant, it's actually the same, you know, on these data sets, it's the same. R said, hey, I'm just being careful. I'm just going to say, hey, these are 2 different fields, and I'm going to go ahead and label them. So that's something just to be mindful of, be ready for. Now for the right join, you'll notice that A, B, C, and D are missing from here. So the A, B, C, and D from the test set are gone because this is a right join. But I, J, K, and L were kept. Now, and you'll notice that since I, J, K, and L are not in the left data set, the fields corresponding to the X data or the left data set are all in A because they didn't have any data in there. Now for full join, this is where nothing is filtered out. All of this, you'll notice that, all right, so here, I, J, K, and L, which are not in the left data set, the X data set, here I have NAs for the fields that are in the X data, but not in the Y. Notice I've got an X here, X, and test. Now over here, when I look at A, B, C, and D, they're not in the right data set, and it's not in the Y data set. So quiz and homework Y, attendance Y, all are missing values. All right, now the dplyr way of doing things. So in general, dplyr is an improvement on R in most aspects. I'm not going to say that's 100% true. Hadley Wickham, please don't hate me. But overall, globally, it's an improvement. So there are 3 types of merges that are in there. There are filter joins, and there are let's see, it's match merging, filter, and nesting, I think. We'll get to it. All right, so let's go ahead and load the dplyr package. So first thing it tells me that from the dplyr package, there is redundancy in function names with the stats package in filter and lag. So dplyr was loaded last, therefore I know that if I run filter lag, it's going to be the dplyr version, not the stat version. If I run intersect, set difference, set equal union, it will be from the dplyr package, not the base package, unless I specify manually. All right, so it's mutate joins. Mutate joins is the first version. And so here I do inner join. And so one thing that's nice about this, so I prefer the regular merge function just because there's one function and I just run it. I don't have to know anything, I don't have to remember the names of them. I don't have to think about it. But for inner join, it gives me exactly the same data set I had previously. And it goes through and it names things the way you'd expect it. If I do SAS and I use proc SQL, SAS would go through and overwrite attendance and homework, just to let you know. So that's something to be mindful of if you're working in SAS. That it would say, hey, homework, I think it overwrites with the right data set. I think what it would do would take homework and overwrite, it would take attendance and overwrite. I'm not 100% sure, but I know it does overwrite one of them. I don't honestly have to play with the test case to know. Left join, I use the left join function. Hey, isn't that convenient? Thank you, Hadley Wickham. And we get exactly what we had before. Notice that we have missing values. And we notice that all the letters from the quiz data set that are not in the left data set were kicked out. Right join, similar story. And then full join. All right. So now there's also these filter joins. So the filter joins are semi-join and anti-join. Semi-join, what it does is it looks for what's in common, and it does, so it filters out. So what it does is it takes the X data set, it looks at the ID variable that is contained within the Y data set and only returns the ones that match. So here, these are the observations in the X data set that would be kept in an inner join. All right. So this is really just filtering out the data. It's not, I don't even consider this a join, but it's called a join, so I included it in this video. If you disagree with me, like go to YouTube and say you disagree. I don't know. Go to the comment section. Why do YouTubers say that all the time? I don't know. It confuses me. All right, now anti-join are the ones that would be kicked out in an inner join. So here, it's going to take the observations that if I did, so it takes the observations in the first data set that would get kicked out in an inner join. And here I can see this, the output. And the nest joins, I don't really understand why we would use this over the others. We can see that it's basically a left join, but the appended part on the left join is different. I don't know what the advantage is. There's help documentation. I've never used it, but it's a join. It was there. It was in the help documentation, so I went ahead and included it. All right, so this is all I got for you. Take care and goodbye.